Hi, in this video we'll be looking at fractions, how we carry out operations on them, and how we simplify them. Let's get started. A fraction is a number written in this form, where b cannot be 0. So a is called the numerator and b the denominator, and normally both a and b would be integers, but that's not necessarily the case all the time. So let's look at an example here. We could have, let's say, 3/4. So this number 4 here is telling us that the whole has been divided into 4 equal parts, and we're looking at 3 of them, or we're interested in 3 of them. We could represent this like a pie of some sort, divided into 4 equal parts, and then we're taking 3 of them, right? So that's 3/4. So when we have fractions, the denominator is the number of equal parts that the whole has been divided into, and the numerator here, in this case 3, indicates how many of those parts then we're referring to. We refer to 3 out of 4. Fractions don't have to be made up of numerators and denominators that are integers. You could have fractions like this. For example, this is a valid fraction. Right, so a fraction like this is called a complex fraction, and we look at this a little bit more later on. Be aware that you can also look at fractions. We also have fractions like this, so 6/6. So this is a 6 part source of 6. That means the whole, right? So you have something divided into 6 equal parts, and you're taking all 6. Then you've taken the entire thing, so that's equal to 1. So any number divided by any numbers, because this can also be interpreted as a division. Any fraction in which the numerator and the denominator are the same will be equal to 1. So 3/3 is 1. 1/2 over 1/2 is 1. This is a very important property, because whenever we multiply by 1, no matter what number we have, 18 times 1 is still 18. So whenever we multiply something that we know is equal to 1, that number remains the same, even though it may look different. That's not the case here, but it certainly will be as we move along. Of course, when you have a fraction, the denominator can never be 0. So this is crucial. This is very important. A 0 denominator would imply division by 0, which is not defined. So be careful. Always keep this in mind. Division by 0 is not defined. You cannot have fractions in which the denominator is equal to 0. Fractions that have the same value are equivalent fractions. Let's take a look at the fraction 2/3. I can multiply this in the numerator by 5 and the denominator by 5. So this would give me 10/15. So let's look at this here. What happened here? We can write this another way. We can say this is 2/3 times 5/5. See? But what's 5/5? This is 1. So in effect, what we have done here is we have taken 2/3 and multiplied it by 1, but we have done it in a way that's maybe a bit clever. We didn't just multiply it by 1. We multiplied it by 1 in the form of 5/5. We just stated that whenever you have a fraction in which the numerator and the denominator are the same, and of course not 0, then when the result has to be the same, because you have multiplied it by 1. So this fraction here is 1, and so I've multiplied 2/3 by 1. So whatever I get, no matter the fact that it looks different, has to be equal to 2/3, because this is the result of multiplying 2/3 by 1. This is very important. Don't just memorize these little things here, like steps and rules. Mathematics is based on a few very basic ideas, and at least much of what we study at this level is based on a few very simple ideas. And things become a lot easier if we just understand these ideas, right? That whenever you multiply something by 1, the result is the same. Right? So if I multiply this by 5/5, I'm in effect multiplying it by 1. Which means then that 2/3 is equal to 10/15, right? So that's what this is saying here. If I have a over b and I multiply it by 1 in the form of c over c, then the result here has to be equal to that a over b, because in effect I've multiplied it by 1. This gives us a way of simplifying a fraction, right? Because if I have some number up here and I can write this number as a times c, and I have some number here and I can write it as b times c, well then c divided by c is just 1, so then this is a over b. So that would be like doing the reverse here, right? I have if I have 10 over 15, I can write that as what? 2 times 5 over 3 times 5, and of course then 5 divided by 5 is 1, leaving me with 2/3. Many of my colleagues like to say that these cancel. I don't like doing that, because then students begin to think that there is some magic operation called cancelling, and it's not that, man. What's going on here is simply 5 divided by 5 is 1. In other words, this is the same as 2/3 times 1. Anything times 1 is just whatever that thing is, 2/3. See? So to simplify a fraction, what we do is find the common factors in the numerator and denominator, and then we simplify. In this case, the common factor was 5, and of course then 5 divided by 5 is 1, so this simplifies down to 2/3. Sometimes it's not going to be so easy to find the common factors, and so what you can do is just express both numbers as their prime factorizations. So let's say we are given 315 over 770. Well, to find the common factors here may be a bit difficult. You might say, well, 5 is obvious, but let's just suppose you don't see it. Well, we can just get the prime factorization. So the prime factorization of 315, the prime factorization of 315 is going to be 3 times 3 times 5 times 7. So go back to an earlier video and review how we do this, right? And the prime factorization of 770 is going to be 2 times 5 times 7 times 11. So obviously here we see that 5 divided by 5 will give me 1, and so then this simplifies down then to and 7 divided by 7 will also give me 1, right? So the common factor was 35. So this simplifies down to 3 times 3, 9, over 2 times 11, 22. So if you do class with me, we will see more of this in class. So let's move on to the next topic. When we multiply fractions, what we do is we multiply the numerators and then we multiply the denominators. So let's take a case like let's say we have 3/4 times 5/7. Well, when we multiply the numerators, we get what? 3 times 5, 15. And when we multiply the denominators, we get 4 times 7, 28. You could multiply the denominators first. 4 times 7, 28. 3 times 5, 15. Alright, and so that's pretty much that. Let's look at division. To divide two fractions, we multiply the first by the reciprocal of the second. So let's take a look at this example here. Let's suppose I have 7 over 18. 7 over 18, and I want to divide that by, let's say, 14 over 27. Well, this is the same as saying 7 over 18 times 27 over 14. And before we carry out this multiplication, because we could simply say 7 times 27 over 18 times 14, but we see that this can be simplified a little bit. So let's do that. So that's going to be 7 over, this is going to be 2 times 9. And then over here I'm going to have 3 times 9. And down here I can see that I'm going to have 2 times 7. And so then this 9 divides into this 9. This 7 divides into this 7. So remember, this would end up being, maybe I should write out that entire thing. Let's say the result of all of this would have been what? 7 times 3 times 9 over 2 times 9 times 2 times 7, see? And so now 7 divided by 7 is 1, 9 divided by 9 is 1, and I'm left with 3 over 2 times 2, 4. Okay. Adding fractions is a simple matter once the denominators are the same. So for example, if I have, let's say, 1/7 plus 3/7, well then that's 4/7. And likewise, if we're dealing with subtraction, you know, it's if I have, let's say, 5/8 minus 3/8, well then 5 minus 3, that's 4/8. Sorry, 5 minus 3 is 2/8. And of course, this can be simplified down to 1/4. Alright, so when do difficulties arise? They arise when the denominators are not the same. So if I have, let's say, 3/4 plus 2/5, we can't just say 3 plus 2 and then, you know, over what? So we have to find the least common denominator, right? We have to find, and so what are we trying to do? We're trying to express both of these as fractions with the same denominator. So technically you could pick any multiple of 4 and 5. So let's, in a way, do it like in a not quite so correct way. I just want to show that it's possible, right? Let's suppose you say I'm going to use 60. Alright, so if I want to express this as 60, well, what did I do here? I multiplied this by 15. In other words, I'm multiplying this by 1. Notice that trick again. We're multiplying it by 1 in the form of 15 over 15. And that gives us 15 times 4, 60. 15 times 3 is 45. Likewise, and this should be plus, right? That's a plus. And then here, if I want a 60, I need to multiply this by 12. So I need to multiply the whole thing by 12 over 12. In other words, I'm multiplying by 1. So 12, 5, 60, 12, 2 is 24. And so one possible answer for this then would be 69 over 60. So I think this is called an improper fraction. You could rewrite this as just see how many times 60 goes into 69. That's 1, leaving you 9 over 60. And of course, then this can be simplified a bit. 3 into 9, 3. 3 into 60, 20. So technically, you can use any common multiple of 4 and 5. However, traditionally how this is done is you find the least common multiple of 4 and 5. And of course, the least common multiple of 4 and 5 will be 20. So we rewrite these then, you know, as for this to be 20, and for the fraction to remain the same, I need to multiply this by 1 in the form of what? 5 over 5, right? So that becomes 15 over 20. And this becomes, again, to get a 20 here, I need to multiply this by 4 over 4, so that, in a sense, everything remains the same, right? And so 4 times 2 is 8. And then this gives me then 23 over 20. Which of course then is equal to 1 and 3 over 20. So notice we get the same answer. The same approach applies for subtraction, so I won't bother going into that now. You should be able to do that. The way this is taught, like in primary school, it's taught very algorithmically. You're just giving a method and it's just something you practice over and over, and of course that's why sometimes, you know, kids don't like see any sense to mathematics. It's just like, you know, you just have to memorize these rules and all these steps. It's important that you see like what's going on, right? It's just a nice logical structure. So the way you're taught this in school is, in primary school, is that you're given these, you find the LCD, you know, the LCM of 4 and 5, and that's 20, and then you say 4 into 25, 5 3 is 15, right? And then you say 5 into 24, 4 2 is 8. And you get the same answer, 23 over 20. I hope you see that why this works is because, in a sense, you're just multiplying each one of these by 1, right? And so there's nothing wrong with a shortcut method like this. It's just that after a while, mathematics, unfortunately for many kids, just becomes like a million shortcuts and then you can't remember them. When it's just a few basic principles in mathematics, when 1 times anything gives you the same number, 0 plus anything, it's the same number. So I hope that you can see that as we progress through this course. Let's say you're given some fraction 3/5, for example, and you want the opposite of this. Well, the opposite of this is minus 3/5. Note we can write it like this, we can write it this way, we can write it this way. But this is the one I, for the most part, prefer. No, I prefer to say minus. So I didn't probably write that as nicely as I should have. Not like this. That's what I meant to write here. So that's basically what we're saying here. So just be aware of this, right? There's nothing wrong with this. And sometimes you want to leave them in, or at least you want to have them temporarily in this form because, well, you're trying to make some point. Right? But on the most part, I keep the negative sign out. I keep the negative sign out here. All right. Let's say you're given this to simplify. You have this expression here. So how do we go about this? Well, you can simplify the numerator or the denominator in turn. It doesn't have to be 1 first. But let's work with the numerator. So we simplify this. This becomes what? That's minus 12 plus a minus 12. You do not absolutely have to put these parentheses, but it helps to keep control of your negative signs. Students often forget that they have a negative sign somewhere, and it can lead to an error. So just use parentheses if that's the problem here. So this will give me a minus 6. And of course then I have minus 2 here like that, right? And then this up here becomes minus 24. And down here I get minus 6 minus 2, then you should know that it's minus 8. And of course then that gives us 3. Fractions that look like this are referred to as complex fractions. So just remember that. And to simplify these, we just apply everything that we've learned so far. So let's tackle the numerator first. You should always make little comments in your work so that someone reading your work can follow along. Another way to do this would be to write this whole thing over and over and over, but then sometimes you don't want to be doing that. So I'm just focusing on the numerator here. So I'm going to deal with the numerator and then I'll deal with the denominator. Comment your work so then, when I look at it, I can understand what you're doing. So this will be 1/2 plus 2/3. Well, what's the common factor here? The least common multiple, that's going to be 6. And then that's going to be what? 3 plus 4. Right? 3 1s 3, 3 2 6, 2 3 6, 2 2s 4, which then gives me 7/6. And then I tackle the denominator. So this is just a suggestion, like how I'm breaking it up. If you have some other way you like to approach these things, fine. Just make sure that it's clear and I can understand. So this becomes 3/4 minus a 1/6, and the LCM of 4 and 6 is 12. So what do I need to multiply this by? By 3/3, right? So that becomes 9, and this 2/2, right? We'll do it. Notice I purposely avoid doing it the way you were taught in private school, 4 into 12, 3 times 3, 9. Because it's important that you get in the habit of seeing how you can simplify things by simply multiplying by 1, right? So, so here I need a 12 here, I multiply by 1 in the form of 3/3, and here I need a 12, so I multiply by 1 in the form of 2/2. And of course then this gives me then 7/12. And then now we're back to our original problem. This is going to be what? 7/6. divided by 7 over 12. This is going to be 7 over 6 times 12 over 7. So remember, when you divide fractions, you multiply one by the reciprocal of the other. And of course, 7 divided by 7 gives me 1. That leaves me with 12 over 6, which of course leaves me with 2. Okay, so that brings us to the end of this video. Again, please, if you have any suggestions, any critiques, please leave a comment. If you're in a class with me, you can bring it up in class if you so desire. I'm always quite open to any suggestions and critiques that you can have, Anyway, so that's it for this video. I'll see you in the next one. Bye.